Last part of thermochemistry that we're going to get into is this thing called Hess's Law. And what Hess's Law is if a reaction is carried out in a series of steps, or what I'm going to call them as smaller reactions or subsequent reactions, the change in enthalpy for the overall reaction equals the sum of the enthalpy changes of the individual steps, or smaller reactions. So what this is going to look like is we're going to be trying to find the change in enthalpy for this overall reaction. We have smaller reactions or subsequent reactions, and we are given their change in enthalpies. And what we're going to have to do is we're going to have to manipulate the smaller reactions. By manipulation, that means we either flip them or we multiply a number through them, so that when we add all the smaller reactions up, we're getting that overall reaction, and we can find the change in enthalpy there. And I have a couple of examples to kind of go through. Start off with a really easy one. So here's our reaction. Carbon plus 1/2 O2 yields to carbon monoxide, and we want to figure out the change in enthalpy. Here is our smaller or subsequent reactions that we're going to have to possibly manipulate. And what we need to do first is we need to see if these smaller reactions have anything unique to them, to the overall, so that we can see what we need to do to it. So in this first reaction, we have carbon plus O2 yields to CO2. In our overall reaction, we have carbon as a solid by itself. Carbon as a solid by itself in here. The second reaction does not have carbon as a solid, so we're going to say this is the unique thing for this first reaction. So carbon as a solid is on the left-hand side, carbon as a solid on the left-hand side. So for this one, we're just going to leave it alone right now. So sometimes manipulating, we just leave things alone. And if we look at our second one, we have carbon monoxide plus 1/2 O2 yields to CO2. Well, we don't have CO2 in the overall. We do have O2, but our first reaction right here also has O2. The thing that's unique to this one is the CO. Now, CO is over on the right-hand side of our overall reaction. So the way that we're going to manipulate this one is we are going to flip the reaction. So I'm going to rewrite these down here so you can see what we have done. Because all this information that's in black ink is already given to us for this type of problem. So we're going to flip that. So I'm going to put CO2 gas yields to, and my advice is when you start manipulating them, line the arrows up so you can see what's on the left-hand side and the right-hand side. CO gas plus 1/2 O2 gas. Now, whatever we do to the reaction, we also have to do to our change in enthalpy. So if we flip the reaction, the change in enthalpy sign is going to be flipped as well. So now instead of having a negative 283 kilojoules, we have a positive 283 kilojoules. So now we're going to add up our smaller reactions, just like what Hess's Law says. And when we add them up, what's going to happen is that if we have stuff in these smaller reactions that are not in the overall, things are going to get canceled out or things are going to be reduced. And the way that things get canceled out or reduced is if we see them on both the left-hand side and the right-hand side. So we have CO2 on the left-hand side and we have CO2 on the right-hand side. These two things are going to get canceled out. Now we have a whole O2 on the left-hand side and we have a half O2 on the right-hand side. The half O2 gets canceled out and this whole O2 is reduced down to 1/2. And once we're done canceling out or reducing, what we should have is the overall reaction that we're trying to find. And carbon solid plus 1/2 O2 gas yields to CO. So we do have our overall reaction again, and to find our change in enthalpy, all we have to do is add up those numbers. So we're going to add up negative 393.5 plus a positive 283 and we come up with negative 110.5 kilojoules of heat. Okay, let's look at our next one. So here is the overall reaction that we're trying to find the change in enthalpy to. Here's our smaller subsequent reactions. Let's try to find what is unique in each one of them. So in this first one, we have C2H2. We do have C2 and H2 in the overall. It's on the right-hand side. The other ones don't have C2H2, so that's unique. So this first one, what we're going to do is we are going to flip it. And when we flip it, our change in enthalpy changes sign. So now we have a positive 1299.6 kilojoules. Now if we look at our second reaction, we have carbon as a solid plus O2 yields to CO2. Well, in our overall, we do have carbon as a solid, but it has a coefficient of 2 on front. And this is the only one that has carbon as a solid by itself. The other, we have C2, which is carbon, but not as carbon by itself. So the way that we're going to manipulate this one is we're going to multiply by 2. So 2 carbon solid plus 2 O2 gas yields to 2 CO2 gas. And like I said before, whatever we do to the reaction, we must do to our change in enthalpy. So we're going to take negative 393.5 times 2. That gives us negative 787 kilojoules. Now our last one. We have H2 plus 1 half O2 yields to H2O. Well, we have H2 on the left-hand side by itself. We have H2 left-hand side by itself. So for this last one, we're just going to leave it alone. Excuse me. So change in enthalpy is still going to be a negative 285.8 kilojoules. So now we're going to add everything up. Do we have things on the left-hand side and the right-hand side that we see? Well, the first thing is we have 2 CO2 gas on the left-hand side. We have 2 CO2 gas on the right-hand side. That's going to get canceled out. H2O liquid, left-hand side. H2O liquid, right-hand side. That gets canceled out. We need that 2 carbon and we need the H2, but we have 2.5 O2 on the left-hand side. Now 5 has O2. 5 has is 2.5. So those things are going to get canceled out. And what we're left with, we have 2 carbon solid plus H2 gas. Well, that's looking like our overall reaction on the left-hand side yields to C2 H2 gas. You know, we have the same overall reaction. So our change in enthalpy, if we add up our numbers, 1299.6 minus 787 minus 285.8. Our change in enthalpy is a 226.8 kilojoules of heat. Now let's look at one more. Okay. So, what do we have unique in this first one to the overall reaction? Well, the first thing that stands out to me is NO, no. No on the left-hand side, coefficient of 1. No on the left-hand side, coefficient of 1. So I'm just going to write the reaction down as we see it. Change in enthalpy, negative 198.9 kilojoules. Okay. Now if we look at our second one, we have O3 yields to 3/2 O2. Well, in the overall reaction, we don't have O3 or O2. So with this one, since we don't have anything in that reaction that's to the overall, that's telling us that we're going to need to use it to cancel things out. So let's kind of come back to that one, and let's look at our third reaction. Third reaction, we have O2 yields to 2O. Well, in the overall, we have monatomic oxygen, O, and it has a coefficient of 1. Down here, it's on the right-hand side and coefficient of 2. So for the third reaction, the way that we're going to manipulate it is we are going to flip it and also divide by 2. So flip it and divide by 2, so we're going to have monatomic oxygen on the left-hand side yields to 1/2 O2 gas on the right-hand side. And now with our change in enthalpy, since we're flipping it, the sign changes. So I'm going to take a negative 495, and I'm going to divide that by 2. Negative 247.5 kilojoules. All right, now let's go back to that second one. We need to cancel things out. Now, we have, in that first reaction, we have O3 on the left-hand side. We don't need O3 in the overall reaction. And we're not going to flip or anything like that with the first one. So what we're going to have to do with the second reaction to cancel out that O3 is we're going to flip it. 3/2 O2 yields to O3 gas. And since we flipped it, that changes our sign. So we have a positive 142.3 kilojoules. Okay, add things up. So like we said, O3 needs to be canceled out. On the left-hand side, we have 3/2 O2, or 1/2 O2. Right-hand side, we have 1.5, so we have 1/2 O2. Those get canceled out as well. No plus O yields to NO2 gas. So we have our overall reaction that we're looking for. Now the change in enthalpies, we take a negative 198.9 plus 142.3 plus a negative 247.5, and I'm coming up with an answer of negative 304.1 kilojoules for an answer. Okay, so I hope this helps you out. If you have any questions, please email me, and I will talk to you later. Thank you for watching.